Let's jump right into this explainer and uncover the staggering, rapid neurobiological and cognitive transformations that happen in a baby's first 2 years of life. We're going to look closely at how a newborn goes from being this incredibly open, universal perceiver to a highly specialized mind tailored entirely to its specific environment. It is, honestly, one of the most fascinating processes in all of human biology.
Now, we've got to start by busting a pretty massive myth. The old belief was that newborns basically just sleep, eat, cry, and soil their diapers. For a long time, even some medical professionals genuinely believed babies were born functionally blind and operated as complete blank slates. But the scientific reality? It's entirely different. Babies are active statisticians. They're actively making sense of their world, taking in data, and actually forming expectations before they even leave the womb.
Section 1. More than blank slates. Let's look at the fascinating baseline of what infants actually know from day one.
Babies possess what developmental psychologists call core knowledge. What this means is that they're born with skeletal competencies, an innate understanding to process the physical world, the biological world, and people right from birth. They aren't starting from scratch at all. They arrive with a basic grasp of really complex concepts, like object cohesion. That's just knowing that an object has boundaries and its parts are connected. They even have a rudimentary understanding of basic quantity. So think of it like this. They come pre-installed with the software needed to start computing the world immediately.
Moving to Section 2, the brain spring cleaning. Let's look at synaptogenesis and pruning.
2 million. Just let that number sink in for a second. At its absolute peak, a developing infant brain is forming an awe-inspiring 2 million synaptic connections every single second. Your brain literally doubles in size in the first year alone. It's an unparalleled explosion of neural growth that basically forms the foundation of human intelligence. This initial massive overproduction of neural pathways is known in neuroscience as synaptic blooming, or synaptogenesis. It is the explosive formation of thousands of new connections between neurons during infancy and toddlerhood. By the time a child hits age 2, a single neuron might have thousands of dendrites branching out, connecting the brain in this dense, almost overwhelming web of possibilities. The brain is essentially over-preparing for literally any environment the baby might happen to find itself in.
But hey, the brain cannot keep all that clutter, right? It's just highly inefficient. So it utilizes a brilliant mechanism called synaptic pruning to clear away the unused connections so the essential ones can really thrive. Think of it as a biological spring cleaning. Up to 40, maybe even 50% of these initial connections are going to be eliminated. The pathways that get used repeatedly, those grow incredibly strong, well-myelinated, and super efficient, while the neglected ones simply die off.
Section 3. Citizens of the world. Let's explore how this biological pruning dictates universal perception. The research reveals this beautiful concept. An infant is born a citizen of the world, not knowing the particular culture, language, or perhaps even primate taxa in which he or she will develop. Because a newborn's brain hasn't gone through that pruning phase yet, they enter the world universally tuned to perceive practically everything. For instance, they can hear the subtle acoustic differences between all human phonemes and all of the world's languages. They are true citizens of the world, totally ready for anything.
Section 4. The perceptual narrowing process. Let's look at how babies go about becoming specialists.
There's a fascinating experiment that perfectly illustrates this concept. Research shows that at 6 months old, babies can easily distinguish between individual macaque-monkey faces. Now that sounds totally crazy to us adults, right? Because they look virtually identical to us. But through a process called perceptual narrowing, infants' brains prune away this unneeded cross-species ability by the time they hit 9 months. Unless they are somehow surrounded by a troop of macaque monkeys on a daily basis, the brain decides this skill just isn't necessary for survival, and that specific neural pathway gets aggressively pruned.
So as the brain continues its spring cleaning, this narrowing fundamentally shapes our entire reality. Infants lose the ability to distinguish foreign speech sounds. They start showing increasing specialization in identifying faces of their own race, which is often termed the other race effect. Even their neural architecture physically tunes to their specific culture's musical sequences. And why does all this happen? Well, it's an evolved mechanism to foster critical social communication. Infants become incredible specialists in their own local culture, shedding those universal abilities to optimize for survival and deep social connection with their specific caregivers.
Section 5. Tracking observable milestones. Now we'll be tracking developmental stages. This timeline reflects the CDC's recently updated developmental milestones. It essentially maps out exactly what 75% of children can physically and cognitively achieve at these distinct stages. At 4 months, you get those amazing early social smiles and cooing. By 6 months, they know familiar faces. Moving along to 9 months, they might actually become shy with strangers, which is a clear sign of that specialized perceptual narrowing in action. At 12 months, we see games like pat a cake. By 18 months, walking without help. And at 24 months, we see 2-word phrases and kicking a ball. This is the observable, beautiful result of all that internal synaptic blooming and pruning we just talked about. Now, to keep things completely objective here, we must note that researchers have heavily critiqued these recently revised CDC milestones over a few key areas of academic concern. Critics point out a lack of speech-language pathologist input during the actual revision process. Furthermore, some of the normative data relied on sources that included non-U.S. populations and lacked diverse socioeconomic data, which raises questions about whether they fully represent U.S. children. Finally, there have been concerns about missing or misaligned empirical evidence, specifically regarding expressive vocabulary milestones. It is a really vital ongoing debate in the field regarding exactly how we establish these critical screening tools.
But regardless of the exact timing of those milestones, the underlying mechanism driving the brain's development remains crystal clear. Ultimately, the biological pruning and narrowing we've been discussing are largely driven by something called the social gating hypothesis. This proves that infants' perceptual learning relies heavily on social interaction. Social contexts quite literally create the optimal learning environment. The research shows that a caregiver's interaction actually increases an infant's arousal and attention, linking perception directly to physical action. It proves that your everyday interactions, chatting while changing a diaper, singing a lullaby, simply making eye contact, are literally physically wiring the infant's brain.
Which leaves us with a pretty profound thought. If every single song you sing and every smile you share physically sculpts an infant's neural pathways, literally deciding which synapses survive and which are pruned away, how will you consciously shape the architecture of the next mind you interact with? Knowing that you hold the blueprints to this incredible developing mind, what choices will you make the next time you encounter a baby? It's a staggering responsibility for sure, but also a completely awe-inspiring one. Thank you so much for joining me for this explainer, and I really hope it completely changes how you view those precious first 2 years of life.